Good evening, everyone. This is lecture 7, I think. Okay. So, lecture 7. We have to move very, very fast now. Reflection through a spherical surface. Okay. Now I'll move fast. Got it or not? Okay. Because this is a crash course of JEE Advanced. So, I am going to move very, very much fast, guys.
आवाज क्लियर नहीं आ रही है।
Gagan, can you hear me clearly?
Yes, sir.
Anuj, I think it is a network problem. Little bit go to the roof or something like that. Today is August 7. एक बार लीव करके ज्वाइन कर लेना तो शायद क्लियर आ जाए 202 ओके चलो तो गुड इवनिंग एवरीवन गुड इवनिंग यूट्यूब फैमिलीज आल्सो सो आज हम स्फेरिकल सर्फेसेस के बारे में पढ़ने वाले हैं मैंने कल क्लियर कर दिया था कि देयर आर हाउ मेनी काइंड्स ऑफ स्फेरिकल सरफेस टू सरफेसेस इन प्रीवियस लेक्चर में कॉनकेव convex okay now in concave we have the reflective surface from inside while in convex the reflecting surface is from outside. Next important point, the focus of the concave mirror lies on the left side of the particular mirror. Second point, curvature also lies on the left only. But in convex mirror, what is the property? Focus lies on the right side of the mirror. Okay, where does the focus lies? Means right side of the mirror, inside the mirror, you can say. And curvature also lies inside it. Okay. Next point, in concave mirror, one property remains still same. Object is kept on the left side always. Object is always kept on the left side for both of the mirrors. And their images position will be definitely different for that. Okay. Now, next important thing, from the object, incident light is going to fall on the mirror from the left side towards the right side. So one important point is that incident light falls from left side of the mirror, and that is the most important thing. Okay, I have talked about real and virtual images. Real images, when reflected light meets in front of mirror, it gives you real images. And when reflected light meets in back of the mirror, they give you virtual images. So based upon all of these properties, these two properties, we are going to talk about concave and convex mirror and different kind of their reasons. Okay, means this concave is also having some kind of particular kind of reason. For different reasons, we have different kind of image formation. We are just going to take a little bit of example of that, then we'll move to forward topic. So first important point, I'm going to, let's suppose if I have a concave mirror, okay, I'm considering about reason 1. Okay, so this is my concave mirror. It has focus over here, center of curvature at this point. Okay, now let's suppose if an object is kept, means first reason I'm talking beyond this center of curvature. Okay, means reason 1 is beyond this center of curvature. Okay, this is my reason 1. So when you place any kind of object beyond the center of curvature, what is going to happen, that their images will be formed between the center and focus. Image distance is what? Between center and focus. Now one more important point, what you are going to observe, that when you are going, let's suppose if the object is placed at infinity, if the object is at infinity, what is happening? Anu's messages, स्क्रीन रुक रहा. ओके, सो रात को तुम देख लेना, रिकॉर्डिंग देखोगे क्या? ठीक है, देख लेना इसको अच्छे से.
रिकॉर्डिंग ट्राई करते हैं.
हाँ, ठीक है. और इसको कंप्लीट करना क्योंकि कल 9:30 में ही क्लास है. ठीक है ना, तो कल मॉर्निंग 9:30 में रेगुलर टाइम पे क्लास हो जाएगा. ठीक है, तो ऑब्जेक्ट
सुबह कर दूंगा.
हाँ, अगर मान लो ऑब्जेक्ट इन्फिनिटी पे है तो इमेज कहाँ पे फॉर्म होता है? अगर फोकस के ऊपर फॉर्म होगा, यस और नो, इस पर्टिकुलर फोकस के ऊपर इमेज फॉर्म होगा. Now, what you are observing as you are moving towards the center of curvature means as the particular when the object was fully at infinity, the image was getting at focus. That means what? If I am moving towards the center of curvature, we are coming nearer and nearer. What is happening? The image, this particular image, first, let's suppose if the object is here, image will be formed over here. If the object is here, the image will be formed at this point. If the object is at this point, image will be formed at this point. So this means what? As you are moving nearer in the region 1, which is this beyond center of curvature, this is my region 1. For the region 1, if you are moving nearer the mirror, image is getting away from the mirror. What is happening? Object, region 1 I am talking about. Object is going near the mirror. Okay, image is getting away from the mirror. First important point, away from mirror. Okay, next point, let us move ahead. Second point, when you place the object between center and focus. Okay, so reason 2 is my this, the reason 2 is center and focus. So this is my reason 2. Okay, I placed the object at center of curvature. So let's suppose if you place the object at center of curvature, what you will observe that you get an image just behind it, means in downward side of it, and you have a real image. So this is my object, it passes like this way. For the focus, it passes like this way. So these lights meet at this point on the center of curvature itself. So in reason 2, what happens? Place the object at COC. What is going to happen? A real image at COC I'm going to get. If I'm forming real image at COC, that means what? For center of curvature, image is going to form at COC. Next thing, if I just move it little bit, if I deflect it from center of curvature towards the focus, image gets away from the mirror again. Means it is moving further away. Okay. So in second reason also, if you are placing at the center of curvature, you will get the image over here on the center of curvature. But if you deflect it little bit towards the right side, means if you move the object from center of curvature to this particular point between the focus and center of curvature, image will be formed beyond center of curvature. Where the image is going to form? Beyond the center of curvature. So what you observe in reason 1 and reason 2, what is going to happen? If I am making the object nearer to the center of curvature, or if I am making the object nearer to the focus, the image is going away from it. What is happening, Agar? The image is going away from it. Are you able to understand or not? Tell me yes or no. This thing. Yes or no? Okay. Gagan? Hello? Okay. Next thing. Next, what is happening? If I place my object at the focus, when I'm going to place the object at focus, where the image will be formed? It will be formed at infinity. The image will be definitely formed at infinity. So second point is at focus, image is at infinity. Okay. So these are the two cases of the reason of concave mirror. Okay. Now moving to the next point. So reason 3 and reason 4. Okay, so now if you have reason 3 is between focus and pole. Focus and pole. Now try to observe. So between, if you place the object between focus and pole, if you place the object at focus, you know that it is the image is forming at if, like if you have object at if, okay, what is going to happen? That image will be formed, image is at infinity. Okay, now next thing is if I place just little bit, if we deflect the object from focus towards the pole, okay, means if I am just deflecting it, what you are going to observe that you are going to get an virtual image just behind the concave mirror at some kind of distance d towards the right. Means try to understand first, in these two reasons image was going away from the mirror, but here when you place the object between focus and pole, image comes near the mirror. What is happening? Image comes near the mirror. Okay, so reason 3 is very much important, between focus and pole. Okay, means when the distance becomes 0, distance of object and mirror becomes 0, and distance of object and mirror becomes focus. So this reason is very much important, because why it is important? Because when I'm going to talk about like where the particular images will be formed and all, So based upon all the distance differences, like whatever it is, I'm going to talk about that kind of things. Are you able to get me or not, Gagan? Yes or no?
Yes, sir.
Okay. Okay, moving to next point. Now try to understand for reason 4. This is most important, last important and very much important reason. Okay, so in every book, I think reason 4 is not mentioned. Okay, if you will go to different kinds of book, reason 4 is not mentioned. Okay, if you want to take the note of it, you can take till reason 3. You can try. Okay.
Sir,
Tell me.
sir, isn't it region 4 and region 3 same, sir?
Okay, so we have what reason 4 and reason 3. No, it is not similar, Gagan. अच्छा हिंदी में भी बोले, ठीक है ठीक है ठीक है, कॉम्पो रियली मैं हिंदी में बोलूंगा.
Sir, because it is between the object is between the focus and the principal focus, sir. Here also the object in region 4 also object is between principal
No no no
focus
no no
and
no 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 no, wait, that is another thing. देखो मतलब रीजन 4 में जो है, रीजन 4 टोटली डिफरेंट है. देखो यहाँ तक जब मीन्स वट एवर वी हैव टॉक्ड, लाइक वट एवर वी हैव डन, जब तक यहाँ तक हमने जो बात की है, हमने क्या किया है, ऑब्जेक्ट्स को लेफ्ट साइड के मिरर में रखा है. मीन्स गगन यू कैन अंडरस्टैंड हिंदी वेल ना? यस और नो?
yes, I can understand, sir.
थोड़ा सा हिंदी में रखते हैं क्योंकि एक बच्चे ने बोला है कि सर हिंदी में भी पढ़ाइए. ठीक है. तो पॉइंट क्या है कि हम जो ऑब्जेक्ट्स हैं, ऑब्जेक्ट्स को हम मिरर के लेफ्ट साइड में रख सकते हैं, है ना? ऑब्जेक्ट को मिरर सारे केसेस में, इन दोनों केसेस में ऑब्जेक्ट्स को हमने क्या किया था, लेफ्ट साइड के मिरर में रखा था. तो उनके लिए हमारे पास डिफरेंट डिफरेंट इमेज की कंडीशन आई थी. ठीक है ना? अभी मैं एक बात करता हूँ, मान लो ऐसा कुछ एक सिस्टम बनाया मैंने. मान लो तुम्हारे पास एक कॉन्केव मिरर है. ठीक है. एक ऑब्जेक्ट के लिए, एक पर्टिकुलर छोटे से ऑब्जेक्ट के लिए तुम्हारे पास एक इमेज मिला यहाँ पे. ठीक है. एक रियल इमेज मिला. अब उस रियल इमेज के लिए ऐसा है कि मतलब यहाँ पे कुछ डिस्टरबेंस हुआ लाइट का, और इस रियल इमेज के लिए तुम्हारे पास एक अनदर इमेज यहाँ पे वर्चुअल इमेज क्रिएट होगा. ठीक है. अब नोटिस करो, इस इमेज के लिए एक अनदर इमेज मेरे पास क्रिएटेड है. ठीक है ना? तो क्या होगा, मिरर क्या करेगा इसके बाद? मिरर इसके बाद एक पॉइंट नोटिस करेगा. वो क्या करेगा, इन दोनों, इन इस ऑब्जेक्ट को और इस इमेज को अपने दिमाग से मिटा देगा. सिंस मिरर इज अ नॉन physical quantity, what he will do, it will erase the property of this object and the real image over there. Okay, what he is going to take, he is going to take this virtual image as some kind of virtual object. ओके, इट इज गोइंग टू ट्रीट, मींस इस वर्चुअल इमेज को क्या करेगा, एक वर्चुअल ऑब्जेक्ट की तरह ट्रीट करने लगेगा कि अरे भैया ये तो मेरे लिए एक ऑब्जेक्ट है. और उसके लिए वो क्या करेगा, कॉनकेव मींस कॉन्वेक्स मिरर की प्रॉपर्टी फॉलो करेगा और उसके लिए इमेज क्रिएट करेगा टुवर्ड्स द राइट साइड. व्हाट ही इज गोइंग टू डू, सो the image, the particular, this virtual image of an object, let's suppose this is my object which has a virtual image over here. For this virtual image, what this mirror is going to do, this mirror will behave like a convex mirror, means ये mirror convex mirror की तरह behave करेगा. और वो क्या करेगा, इस image को एक virtual object की तरह treat करेगा और उसका एक another image form करेगा towards this side, and this is called as real image. Again एक real image create करेगा. सो दिस इज द प्रॉपर्टी ऑफ कॉन्वेक्स मिरर, कॉनकेव मिरर. कि मतलब अगर कॉनकेव मिरर में तुम अगर किसी ऑब्जेक्ट को फोकस और पोल के बीच में रखते हो, तो देयर इज अ 98% चांस कि तुम्हें दो इमेजेस मिलेंगे. कितने इमेजेस मिलेंगे? टू इमेजेस मिलेंगे. वन इमेज तो भैया इसका जो तुम्हारे पास वर्चुअल इमेज क्रिएट होकर आ रहा है, वो उस वर्चुअल इमेज के लिए तुम्हारे पास एक रियल इमेज बन के आएगा जो तुम्हें विजिबल होगा. So there are two images that will be formed for an object placed between focus and pole, and that's why we are going to call this as reason 4. Okay, got it or not? Means too much. Reason 4 is too much nearer to the pole, to the pole, and towards right of mirror. मतलब नोटिस करो कि अभी तक मीन्स इन सारे केसेस में, इन सारे 1 2 3 केसेस में हमने क्या ऑब्जर्व किया कि भैया जो भी हमारे पास इमेज बन रही थी वो राइट साइड में बन रही थी. ठीक है. एक रीजन 3 आया जिसमें मतलब अगर हम ऑब्जेक्ट को फोकस और पोल के बीच में रखते हैं तो उसके लिए हमें क्या गगन मिला, वर्चुअल इमेज मिला. लेकिन ये वर्चुअल इमेज क्या चीज की तरह एक्ट करने लगता है, दिस इमेज स्टार्ट्स टू एक्ट एज अ दिस इमेज, दिस पर्टिकुलर वर्चुअल इमेज एक्ट्स लाइक अ वर्चुअल पॉइंट ऑब्जेक्ट. ये वर्चुअल इमेज जो है वो तुम्हारे पास एक वर्चुअल पॉइंट ऑब्जेक्ट की तरह वर्क करने लगता है. ठीक है। और उसके बाद वो क्या करता है, इस वर्चुअल ऑब्जेक्ट के लिए, मींस इस पर्टिकुलर वर्चुअल ऑब्जेक्ट के लिए हमारे पास क्या बन के आता है, एक रियल इमेज वो क्रिएट करता है। कहां पर रियल इमेज क्रिएट करता है, तो बिटवीन फोकस एंड पोल। सो इट क्रिएट्स an object moves away from the pole magnetic limit. So image is irreal, erect and small. So what does happens if you have a virtual object? Fourth case, if you have a virtual object, that is a virtual image of a real object, ठीक है। अगर मान लो वर्चुअल इमेज फॉर्म होता है किसी रियल ऑब्जेक्ट का, तो उस वो जो वर्चुअल इमेज है एक वर्चुअल ऑब्जेक्ट की तरह वर्क करने लगता है। एंड दिस वर्चुअल ऑब्जेक्ट अगेन क्रिएट्स अ रियल इमेज which is small, erect and real. Got it or not? Gagan, are you able to understand or not? So दो प्रॉपर्टी था।
Sir,
हाँ बोलो।
sir, but this virtual object, sir, for that reflection to happen, but this side it is polished, right? So it can't reflect.
Uh, uh, uh,
Reflection.
that is another thing na Gagan. That is this reflection property. This reflection property is due to the object which is emitting the light. Okay, but this virtual object can see this virtual object also have that kind of property that it can what how to say, you are asking a really dangerous question now, means कि सर ये इनसाइड में कैसे क्रिएट कर सकता है। तो भैया एक पॉइंट है कि अगर मान लो, नोटिस करना, देखो नोटिस करो कि जब हम बोल सकते हैं कि अगर मान लो ये मिरर है, इसके सामने अगर हमने ऑब्जेक्ट रखा, इसको हम बैक ट्रेसिंग करते हैं तो ये जाके मिल जा रहा है, ठीक है। जब हम ये बोल रहे हैं कि यहाँ पे इमेज क्रिएट कर दे रहा है, तो हम ये भी बोल सकते हैं ना कि इस इमेज की तरफ से एक लाइट निकल रही होगी जो इस ऑब्जेक्ट के ऊपर जाके, तुम खुद सोचो। अच्छा एक एग्जांपल लेते हैं, बहुत अच्छा एक एग्जांपल है मेरे पास, ठीक है, बहुत अच्छा एक एग्जांपल है इस चीज को पूरी तरह से समझाने के लिए। एक मिरर ले लो, ठीक है, एक मिरर ले लो, यहाँ पे ऑब्जेक्ट है और ये उसकी आई है यहाँ पे, ठीक है ना, यहाँ पे एक आई है, ठीक है। इस ऑब्जेक्ट का मान लो लाइट फॉल कर रहा है, यहाँ पे फॉल करवाते हैं, ठीक है, अनदर लाइट यहाँ पे फॉल कर रहा है, ठीक। सो लाइट विल बी रिफ्लेक्टेड लाइक दिस वे, this will be like this way. If you back trace it, if I am going to do the back tracing, they are going to join somewhere, okay. So let's suppose they are joining over here, okay, at this point. So here an image will be created, but try to understand Gagan. Now try to understand, everyone who is watching on the YouTube also, you can have this question very much, this question is very much frequent कि सर हमें दिखाई कैसे देता है, ठीक है। सो लिटिल बिट ऑफ दिस पर्टिकुलर, ये जो डिस्क्रिप्शन है वो थोड़ा सा मैं एक और एक बार और डिस्कस कर रहा हूँ। मैं क्या बोल रहा हूँ कि लेट सपोज इफ दिस पर्सन इज देयर, इट हैज आई ओवर हियर, ओके। So from this person, two light rays went, okay, these two light rays went over there, and what it created, for these two light rays I have a reflected rays, sorry, wait, one point, for this light and this light I have the reflected rays. Now जब हम इस इन दोनों रिफ्लेक्टेड रेज को बैक ट्रेस करते हैं तो वो इस पॉइंट पी पे जाके मीट कर रहे हैं। बट एक बात बताओ गगन, इस आई को कैसे दिखाई पड़ रहा है कि इस पॉइंट पे जाके लाइट मीट कर रही है, नहीं ना। तो क्या हो रहा है, लाइट रिफ्लेक्ट की, ठीक है, इसके वजह से यहाँ पे इमेज, वर्चुअल इमेज तुम्हारे पास क्रिएट हो गया। बट ये वर्चुअल इमेज एक अनदर इमेज क्रिएट कर रहा है, इस पर्टिकुलर सेम लाइन ऑफ ट्रेसिंग को यूज करके इस पर्टिकुलर आई के ऊपर वो एक क्या बना रहा है, रियल इमेज क्रिएट कर रहा है। इस वर्चुअल ऑब्जेक्ट का जो वर्चुअल इमेज बना है वो वर्चुअल ऑब्जेक्ट में चेंज हो जाएगा और उसका एक रियल इमेज इस आई के ऊपर फॉर्म कर रहा है। एंड दैट इज हाउ दिस पर्सन इज वाचिंग हिज इमेज ओवर हियर, करेक्ट और नॉट। मींस इस पर्सन को कैसे दिखेगा ये इमेज, जब तब तक नहीं दिखेगा ना जब तक कोई इमेज, तुम्हें मालूम है ना आई कैसे वर्क करती है, आई के अंदर लाइट जाता है, एक इमेज रेटिना के ऊपर फॉर्म करता है, तब जाके हमें विजिबल होता है कि नहीं गगन, कोई पर्सन, यस और नो, टेल मी,
Yes, sir. Yes,
yes or no? So that means what, light should, if I'm watching in a like मैं एक मिरर रख के मिरर के सामने देख रहा हूँ, तो उस मिरर के सामने अगर देखता हूँ तो मेरी फेस कैसे विजिबल होगी, जब तक मिरर के तरफ से लाइट मेरे आंखों में जाके नहीं पड़ेगी मेरे को फेस विजिबल नहीं होगा ना, है कि नहीं। लेकिन मैं अपना फेस क्लियरली देखता हूँ कि नहीं देखता हूँ मिरर, वो इसलिए देख पाता हूँ क्योंकि पहला मेरा इमेज मिरर बना रहा है, उसके बाद वो जो इमेज एक ऑब्जेक्ट की तरह ट्रीट हो रहा है उस पर्टिकुलर मिरर के अंदर, उसके बाद से उस ऑब्जेक्ट से एक वर्चुअल लाइट निकल रही है जो कि रियल इमेज मेरे आई के ऊपर फॉर्म कर रही है, एंड दैट्स व्हाई इट इज दैट इमेज ऑफ मी इटसेल्फ इज विजिबल टू मी। अंडरस्टूड और नॉट, टेल मी। Got it or not? Yes or no, Gagan?
Yes, sir.
Now this example was perfect, na?
Ah,
Got it.
yes, sir.
So this is what happens. Every virtual image can be treated as virtual object and it will form one real image to the another side of the mirror. Means कोई भी virtual object को हम कोई भी virtual image को virtual object की तरह treat कर सकते हैं और उसके लिए हम एक real image another side of the mirror के another side of the mirror में हम बना सकते हैं and that image will be actually a real image. Got it or not? So actually concave mirror have mainly three parts. One part is appearing, one reason 4 is appearing due to the nature of this virtual image. Okay, so you have four reasons in the case of concave mirror. Similarly, now if someone asks you that based upon these four reasons, can you draw, can you draw the graph between the particular virtual image distance and object distance? Okay, so this was the question of JEE Advance. Okay, and there was also a question in the particular JEE Mains. Okay, so before going to that, I'll little bit go through it. Means, let's suppose if I have virtual, sorry, if I have image distance and if I have object distance. If someone asks you that plot the graph of image distance with respect to object distance for which kind of mirror? Concave mirror. Okay, so how to draw it? That is a very interesting question. Like how to draw it, the most important point is when I'm going to draw, we need to consider these reasons over here. Means I have to take into consideration of reason 1. मुझे इस reason 1, reason 2, reason 3 और reason 4 के consideration को लेकर चलना होगा, तभी मैं क्या कर पाऊंगा, इस particular image distance और object distance के ऊपर मैं ग्राफ ड्रॉ कर सकता हूँ. लेकिन कैसे ड्रॉ करूंगा? तो तुम्हारे पास reason 1 है. चलो सबसे पहले रीजन 1 की प्रॉपर्टी यूज करते हैं. रीजन 1 में क्या बोला था मैंने कि इफ यू हैव अगर मैं सेंटर ऑफ कर्वेचर के ऊपर ऑब्जेक्ट को प्लेस करता हूं तो आई गेट एट सेंटर ऑफ कर्वेचर. मींस इफ ऑब्जेक्ट इज प्लेस्ड एट सेंटर ऑफ कर्वेचर आई गेट इमेज एट सेंटर ऑफ कर्वेचर. नाउ मोस्ट इंपोर्टेंट थिंग अबाउट दिस मिरर्स इज व्हाट, ट्राई टू अंडरस्टैंड that left side of this mirror has a negative value, right side of the mirror has positive value. Yes or no, Gagan? Tell me.
Yes, sir.
Yes or no? Huh? 1 minute, one call is there. Hello. हाँ दी, मस्त था. हाँ, मजा आ गया. रियली पेट भर गया. हाँ, रियली रियली इट वाज ग्रेट दी. नहीं 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 दी. हाँ, ठीक है. बाय दी, गुड नाइट दी. क्लास ले रहा हूँ, लेक्चर ले रहा हूँ. ठीक. हाँ, हाँ. Okay, so let us move to this point. What I'm saying is that we have four reasons. One most important point about concave mirror is if you what we say, like on the left side, let's suppose if you measure any kind of distances along the direction of incident ray, means this incident ray is moving towards this side. If I measure the distances along this side, means अगर हम distances को measure करते हैं incident ray के direction में, then these distances will be called as positive distances. लेकिन अगर मैं जस्ट अपोजिट मेजर करूं इस इंसिडेंट रे का, मींस अगर इंसिडेंट रे राइट साइड में जा रही है और मैं डिस्टेंसेस लेफ्ट साइड में मेजर करता हूं तो वो डिस्टेंसेस क्या कहलाएंगी? नेगेटिव डिस्टेंसेस कहलाएंगी. तो यहां पे अगर मान लो तुम्हारे पास एक कॉनकेव मिरर है, ठीक है, और अगर मान लो लाइट फॉल कर रही है कहां से भाई साहब? तो फ्रॉम द लेफ्ट साइड टुवर्ड्स द राइट साइड. ये तुम्हारे पास फोकस हो गया, ये तुम्हारे पास सेंटर ऑफ कर्वेचर. तो तुम नोटिस करो इंसिडेंट रे की डायरेक्शन क्या है अगर फ्रॉम लेफ्ट साइड टुवर्ड्स राइट साइड और नॉट, टेल मी. एंड यहाँ पे तुम्हारे पास पोल है. अगर तुमसे कोई पूछे कि फोकल लेंथ पॉजिटिव होगा या नेगेटिव, तो तुम क्या बोलोगे? ऑफ कोर्स यही बोलोगे ना कि सर इट इज नेगेटिव. व्हाई? क्योंकि तुम जब फोकल लेंथ मेजर करते हो तो कैसे मेजर करते हो? टुवर्ड्स द लेफ्ट साइड. करेक्ट और नॉट? मींस तुम लेफ्ट साइड की तरफ मुड़ते हो व्हिच इज अपोजिट टू द डायरेक्शन ऑफ इंसिडेंट लाइट. दिस मेजर ऑफ फोकल लेंथ, this measure of focal length is opposite to the direction of incident ray. And that is why ये जो फोकस का साइन कन्वेंशन होगा वो एक्चुअली में क्या होगा तुम्हारे पास? It will be negative. Got it or not, Gagan? Similarly, center of curvature will be also negative, and object distance will be also going to be negative. Yes or no? Why? Because all the objects are placed on the left side of the concave mirror. But the image distances, it depends. If the image is forming towards left side, it will be negative. If the image is forming towards right side, the image distance will be positive for the concave mirror. If image towards or image in front of mirror, you know what kind of image I have? These are real images. So हर एक रियल इमेज कॉन्केव मिरर के लिए कैसा कैसा इमेज डिस्टेंस देगा? नेगेटिव इमेज डिस्टेंस देगा. हर एक इमेज इन बैक ऑफ कॉन्केव मिरर. तो मालूम है कि बैक इस राइट साइड में जो इमेज बनते हैं कॉन्केव मिरर के लिए वो वर्चुअल इमेज बनते हैं. So virtual image for concave mirror has positive distances of calculation. Understood or not? Tell me yes or no. Negative, positive. This consideration of negative and positive. Is it okay or not? Gagan, yes or no?
Yes, sir. Yes, sir.
Okay. So based upon this, let us try. Means इसके इस पूरे कंसिडरेशन को लेकर हम अभी ग्राफ प्लॉटिंग करने वाले हैं. तो तुम्हें मालूम है कि अगर मान लो हम सेंटर ऑफ कर्वेचर के ऊपर ट्वाइस ऑफ एफ नॉट मींस वो क्या हुआ? सेंटर ऑफ कर्वेचर हुआ. तो अगर मान लो ऑब्जेक्ट को मैंने क्या किया? लेफ्ट साइड के कॉन्केव मिरर में रखा. मींस ये कॉन्केव मिरर है, मैं यहाँ पे सेंटर ऑफ कर्वेचर है ट्वाइस ऑफ एफ नॉट, और ये एफ नॉट है फोकल लेंथ. यू नो दैट लेफ्ट साइड में सेंटर ऑफ कर्वेचर होता है कॉन्केव मिरर का, वो नेगेटिव होगा. सो इफ आई प्लेस माय ऑब्जेक्ट एट सेंटर ऑफ कर्वेचर, वी नो दैट द इमेज इज आल्सो फॉर्म्ड एट सेंटर ऑफ कर्वेचर. ये सर जो भी इमेज फॉर्म होता है वो सेंटर ऑफ कर्वेचर के ऊपर फॉर्म होता है. ये इमेज डिस्टेंस हो गया, ये ऑब्जेक्ट डिस्टेंस हो गया. अगर मान लो सेंटर ऑफ कर्वेचर के ऊपर इमेज बना, तो सबसे पहले कैसा बनेगा? अगर रियल बनेगा कि नहीं बनेगा? जब रियल इमेज बन गया है तुम्हारे पास, तो ये वैल्यू क्या होगी? नेगेटिव होगी, और ये माइनस ऑफ 2f0 के बराबर होगा. सो फॉर एन ऑब्जेक्ट दैट इज प्लेस्ड एट सेंटर ऑफ कर्वेचर व्हिच इज एट माइनस ऑफ 2f0, इसका इमेज भी कहाँ पे बनेगा? सिमिलरली माइनस ऑफ 2f0 पे बनेगा. तो वहां पे तुम्हारे पास, अगर मैं इस पॉइंट को पता करना चाहूँ कि कहाँ पे लाई कर रहा है, so this point will be lying over here. You can see over here that this object which is kept at 2f0 has an image at minus of 2f0. Got it or not? Yes or no?
Yes, sir.
Yes or no? Okay. चलो आगे बढ़ते हैं. इस प्रॉपर्टी को यूटिलाइज करते हैं, ठीक है ना. अब नोटिस करो कि जब हम क्या करते थे, अगर हम ट्राई करना, जब हमने ऑब्जेक्ट को इंफिनिटी पे रखा था, जब हमारा ऑब्जेक्ट एकदम से when my object was at infinity, which kind of infinity? Minus infinity. So ऑब्जेक्ट जब तुम्हारे पास माइनस इन्फिनिटी पे था, तो जो तुम्हारे पास इमेज बन रहा था वो कहाँ पे बन रहा था? फोकल लेंथ पे बन रहा था कि नहीं बन रहा था? माइनस ऑफ एफ नॉट. यस और नो? सो माइनस ऑफ एफ नॉट कहाँ है? माइनस ऑफ एफ नॉट तो तुम्हारे पास ये है. तो अगर इसका मतलब क्या है कि अगर मान लो अगर मेरा ऑब्जेक्ट माइनस ऑफ इन्फिनिटी है, ऑब्जेक्ट एकदम से इन्फिनिटी पे है, जैसे ये ऑब्जेक्ट डिस्टेंस है, ठीक है, ये ऑब्जेक्ट डिस्टेंस शो कर रहा है, तो ऑब्जेक्ट डिस्टेंस अगर माइनस इन्फिनिटी आ रहा है, तो मेरा जो इमेज बन रहा है वो कहाँ पे बन रहा है? समवेयर नियर द फोकस बन रहा है कि नहीं बन रहा है? समवेयर नियर द फोकस. यस और नो? दिस लाइन शोज व्हाट? दिस लाइन इज शोइंग, this line is showing, try to understand, this is my image distance, this is showing minus of f naught. So इसका मतलब क्या? अगर ऑब्जेक्ट हमारे पास इन्फिनिटी पे है, तो जो इमेज बनेगा वो कहाँ पे बनेगा? माइनस ऑफ एफ नॉट के लाइन के ऊपर बनेगा, ठीक है ना. जब माइनस ऑफ एफ नॉट के लाइन के ऊपर बन रहा है, अब नोटिस करो, जैसे जैसे मैं इन्फिनिटी से सेंटर ऑफ कर्वेचर के पास आ रहा हूँ, मेरी इमेज डिस्टेंसेस दूर जाती हैं कि नहीं जाती हैं? लगन, यस और नो? Yes or no? My image distances goes away from me or not?
Yes,
So
sir.
this is my f naught.
Yes, sir.
Try to understand. For image at infinity, the image for object at infinity, the image was forming at minus of f naught. But when I move away, when I move when I move towards the center of curvature, what is happening? The image distance is increasing from minus of f naught to twice of f naught. But how to draw this diametrically? What will happen? So I'll have to draw like this way or not? Tell me yes or no. What kind of curve I'll get? I'll get some kind of curve over here.
Rectangle.
Why I'm going to get a curve? Because we know that 1 by f is equal to 1 by v plus 1 by u, means the image distance and object distance is related inversely. So that is why we have to take into this as consideration. Got it or not? Yes or no, Gagan? Understood or
Yes,
not?
sir.
Okay, second point. Now you try to understand, when I'm going from this twice of f naught, this is my center of curvature, when I'm moving from center of curvature towards the focus, means in this particular region, what is happening? The image is getting away from the center of curvature. So when I'm moving towards, when I'm just taking my object towards, try to see this. This is my object moving towards the focus. When I'm moving it, the image is getting away from the center of curvature. So I have a graph like this way. Understood or not? First reason, two reasons completed or not. So this is reason one, and this is for reason two. Okay, understood? Gagan, yes or no?
Yes, sir.
Okay, so let's suppose this is what it is. So if you have image distance, if you have object distance, sorry, this is object distance, this is image distance. So if I draw, so first for reason one, I have the graph like this way from here to here. For reason two, I have the graph like from here to here. Means if I take my object to be at infinity, the image will be formed at focal focus. If I take my object to be at center of curvature, the image is formed at center of curvature. If I go away, like if I go nearer, if I move nearer from center of curvature towards the focus, this is my focus. So what is going to happen? Image is formed away from the center of curvature, beyond center of curvature. So the first reason one and reason two is completed. Now move to next point. Now you know that when I place the object at focus, let's suppose this is my concave mirror. When I'm placing the object at this focus, we know now image is formed at infinity. So when I place the object at focus, what is happening? Image is formed at infinity. So image is formed at infinity over here. Understood or not? So try to understand. See this, what is happening when the object is placed at the focus? Image is forming at infinity. So this is your reason 3. Understood? Now another thing is going to happen. You know that when I place the object, let's suppose what is going to happen. This is my concave mirror. Okay. And on this concave mirror, if the object means, let's suppose the virtual object is at infinity, means this virtual object is at infinity. So what is going to happen? For that virtual object, all the lights are going to meet at the focus and they are going to create the image at minus of f over here. Yes or no? So when the object distance, like for the reason 4, if I have the object distance equal to infinity, what is going to happen? The image is formed at minus of f. Understood or not? So this is the representation of image distances with respect to the object distances for a concave mirror for all the reasons. Reason 1, reason 2, reason 3 and reason 4. Understood or not? Tell me yes or no. Yes or no, Gagan?
Yes, sir.
Understood now? So this was the whole important thing. This has came in JEE Advanced. Okay. Like they asked directly, and this has also came in JEE Mains. Okay. Now try to understand one more important point. Like if I ask you that if I consider 1 by V and if I consider 1 by U, you have to draw the graph for concave mirror. Can you draw it? Try to draw it. The graph for 1 by V with respect to 1 by U for concave mirror. What should be it? Gagan, any idea? What should be the
Sir,
graph?
yes, sir.
Yeah, tell me.
Sir, 1 minute.
Okay, I'll tell you one trick for this kind of things. Okay, many people will get confused on this. Okay, so there is no point of confusion, got it or not? I'll tell you one trick for how to do this graph problem of 1 by V and 1 by U. Everywhere it will be asked in the lenses also, in mirrors also. So you know that in mirror formula is what? 1 by F is equal to 1 by V plus 1 by U. You know that. I can write this as, I can write this 1 by V as 1 by F minus 1 by U. If you take the LCM, you can write V as U into F divided by U minus F. If you have still the problem, what you do, take V, take U common over here, it will be F by 1 minus F by U. Okay. So this is the relation, means you got one relation for image distance with respect to object distance. This is b is equal to f by 1 minus f by u. Now I can take the inverse proportional of it. So 1 by v is equal to what? It is equal to 1 minus f by u divided by f. Yes or no? What you observe, it is very very much clear that 1 by v is directly proportional to minus of 1 by u. Yes or no, Kagan? Yes or no? Tell me. What is happening? Try to see. Can I write? See, try if I take u common, it will be 1 f by u. You get cancel. Yeah, it is correct. So what you observe that I can divide this f. So what I will observe that 1 by v means you try to understand if your focal length is very much constant. If your focal length is constant. So what I get? I get one relation that 1 by v is directly proportional to 1 by u. Now you know that for a concave mirror, image distance is nothing but negative. So that means what? 1 by v is directly proportional to 1 by u for concave mirror. Yes or no? If what remains constant? Focal length remains constant. That is the most important property. So if someone says you what will be the graph of 1 by v with respect to 1 by u for a concave mirror, it will be perfectly a sagalaga boom boom linear graph. What kind of graph, Gagan? It will be perfectly a linear graph for 1 by f with respect to 1 by u with respect to 1 by v for concave
Sir,
mirror. Tell me.
sir,
Huh.
sir, if V increases, U must decrease, right, sir?
Uh, that is uh, that is dependent upon different cases or not, Gagan? Reason 1, reason 2, reason 3, reason 4.
Sir,
Huh.
like this, sir. See, sir, one by F is equal to one by V plus one by U.
Huh. Yes.
Sir, so one by F is equal to one by V plus one by U.
Both are
So,
in both are in
sir,
inverse
one
ratio
minute,
or like.
sir,
Huh.
sir, like this, sir, like one by F minus one by V will be equal to one by U.
Huh. Yes.
Now, if U is increasing, sir,
Huh.
one by F minus one by V must decrease.
Why?
Sir, because if U is increased, the denominator is increasing.
Wait.
So the total value on the left hand side must decrease.
So Gagan, one more important thing you need to consider at that time, that when you are taking that particular ratio, it is in inverse ratio or not. It is like 1 by v, right or not? Like what you are saying, 1 by f minus 1 by v is equal to 1 by u. So here one point is there that if what we say, if a is inversely proportional to b, if b increases, a decreases. That is my relation. But what if happens if 1 by a is inversely proportional to 1 by b? So if b increases, a also increases. If b decreases, a also decreases. That is the relation or not? Got it? Because proportionality is not going to change anything. But if you take, like if I just change it 1 by a, this proportionality, there will be no change of proportionality because this is not a greater or lesser sign. Okay. So it's just changes. Like if I take 1 by a, they become directly proportional to each other. Understood or not? Tell me. Got it or not? So I told you now, there will be misconception in this. Yes or no? Gagan? Hello? Okay. Are you sending something? Hello?
Sir, yes, sir, I have sent.
Yeah, yeah.
No, sir. Sir, sir, I got like this.
I'll just check. I'll just check. Arey, Gagan, that's what I'm saying. See, like try to see this relation. If A is inversely proportional to 1 by B, if B increases, A decreases or not. You are aware of it. Tell me yes or no. But if one point happens, like if 1 by A is inversely proportional to 1 by B, so what is going to happen then? If B increases, A also increases or not? Tell me. Got it or not? So this is the main relation. If here if 1 by a is inversely proportional, or if 1 by a is written as proportional to 1 by b, so if b increases, a also increases. That is the relation. Now yeah, if you can why I can do it, because all have similar powers. Okay. Now next point is over here, what you observe that 1 by v, you have written one thing over here, 1 by f minus 1 by v is equal to 1 by u. You are telling like this. But f is negative over here or not, Gagan? Minus 1 by f it is. So minus 1 by v, it is equal to minus 1 by u. If you take all the minus common, actually you are getting in for concave mirror, 1 by u is equal to 1 by f plus 1 by V. Now it depends upon this image, if whether my image is real or virtual. So you directly you can't consider if your object is negative only for focus, only for between
Yes,
this
sir,
focus.
understood, sir. Yes, sir. So,
But
sir, if we take that sign convention, sir,
uh,
then we'll get that U will be directly proportional to
equal to
V.
1 by V. Got
If
it?
U increases, V also is.
Uh, so
Yes,
it
sir. Yes, sir.
depends. That's what I told. Now, this graph is only for concave mirror. Means this linearity is attained only for concave mirror. Understood or not? For convex mirror,
Yes, sir.
it will be perfectly different. Okay.
Yes, sir. Yes.
Okay. So based upon this, what you will have to do that I have drawn for concave mirror. See, wait. Yeah. So here in this graph, they didn't have taken the sign convention. So if they didn't take the sign convention, try to see this when they have drawn, like when if I have -1 by, if I place object as like let's suppose if the image distance as infinity. So if the object is at focus, what is going to happen? Like try to understand. If the object is at focus, so object distance will be minus of f. You know that 1 by f is equal to 1 by v minus 1 by v plus 1 by u. So 1 by v will be what? Minus 1 by f, and it will be like since it will be minus 1 by f already. So 1 by v becomes how much? It becomes 0 for it. So when you draw, let's suppose if I didn't take the sign convention, so what kind of graph I'll get for f is equal to, like if I place object at focus, the image will be from that. Image will be 0, image distance will become 0 for that. If I place the image to be at focus, like let's suppose if the object is a image is that focus, you will get u to be equal to 0 for that. Okay, so this means
Sir,
what?
sir, sir, 1 by V cannot be equal to 0, sir.
I
Because how can you make 1 by V, sir?
wait. This
V will from 0 to.
wait. So wait, without, let me give the heading without sign. Sorry, without the consideration of uh, practical practicality. Okay. If I didn't consider the practical cases of it, what is going to happen? Try to understand that 1 by v will be equal to 1 by f minus 1 by u. You know that. So if I place my object to be at focus, if my object is at focus, you know that for convex mirror, a concave mirror, object distance is always negative. So if I place it as focus, so object distance will be minus of f. Next point is for concave mirror. These are for concave mirror. Focus is itself also negative for it. Okay. So both of the things are negative. So if I put it over here in the equation 1, okay. If I put it in equation 1, what is going to happen? 1 by v is equal to 1 by f negative minus 1 by f. So if you calculate it, what you are going to get? You are going to get it at to be equal to 0. That means what? That if the, like it's not 0, try to understand. Magnitude wise, 1 by a v is equal to 0, means 1 by v is equal to 0. Got it or not? Try to understand, Gagan, what I'm saying. 1 by v is equal to 0. I'm not saying that image distance is 0. If you try to calculate the image distance will be what? That v will be equal to 0, 1 by 0, which is equal to infinity. Understood or not? So image distance is infinity, but your 1 by v is how much? It is equal to 0 over here. Understood or not? Got it? So if your object is at focus, 1 by v is equal to 0 for it, but the image distance is at still at infinity. So if I place my object to be minus of 1 by f, I get my image at 0 over here on this axis. Similarly, if I take image, like if I just try to consider that object is at infinity now, object is at infinity. Now you know now if object is at infinity, what will be particular 1 by u? It will be again, it will be equal to 0, yes or no? But what is going to happen? 1 by v will be again 1 by f minus 1 by u. Now you know that 1 by u is equal to 0. Focal length is negative. So 1 by v is how much? Minus 1 by f. So here you got again minus 1 by f. You know that previously already I told that 1 by v varies directly proportional with 1 by u. So what kind of graph it will be there between f and minus 1 by f? It will be a perfectly linear graph. Understood or not? Gagan, yes or no? Understood or
Yes,
not?
sir.
Okay, I can join it like this way, so it will be graph like this way. Okay, so this is the consideration for all the reasons, like all reason 1, reason 2, reason 3, reason 4. This is only this graph which I have drawn. This is only for reason 1. It is valid only in reason 1 and reason 2. Right or not? So this is for reason 1 and 2, and this is for reason all the reason which I have considered. That reason 1, this is for reason 1, reason 2, R2, R3. Okay, and this is for R4. Understood or not? Four cases, four reasons of concave mirror, and for four reasons, I have the four parts of graph over here. Got it or not? Again, yes or no? Tell me. Now it will be your duty
Correct,
to
sir.
say how it is between reason 1 and reason 2, how it is between reason 3 and reason 4. You have to establish the relation. Okay,
Yes, sir.
got it or not? Okay, so based upon this, like you'll have to try for convex mirror. You know that for convex mirror, I have one property that the inside is polished for it. If inside is polished, what is going to happen for convex mirror? Okay, I should not take like this. One of the biggest problem here in sign convention, I do not know who made the sign convention. Okay, I was not the scientist at that time. मैं तो साइंटिस्ट नहीं था भाई, कब बना के चले गए पता नहीं. ओके, तो सबसे बड़ी बात क्या होती है? अगेन, इंसिडेंट लाइट जो फॉल करती है, इंसिडेंट लाइट आई थिंक, oh wait, it's very bad. I'm not aware how to draw the convex mirror. Okay, yeah, it is like this. Polished surface is like this. Okay, now incident light falls from the left side. Object is still placed on the left side. This is my object, left. Okay, incident right. This is my incident light. Okay, it is going to fall over here and it is going to diverge away from this point. Okay. If it is going to diverge away, what I see that I have focus inside the convex mirror and center of curvature inside the convex mirror. So sign convention tells us what is going to happen, guys. You know, ऑब्जेक्ट डिस्टेंस क्या हो जाएगा तुम्हारे पास? नेगेटिव हो जाएगा. फोकल लेंथ क्या हो जाएगा? पॉजिटिव हो जाएगा. सेंटर ऑफ कर्वेचर डिस्टेंस जो हो जाएगी, जो आर की जो वैल्यू हो जाएगी, वो भी क्या हो जाएगी? पॉजिटिव हो जाएगी. सो यहाँ पे तीन क्वांटिटी तुम्हारे पास पॉजिटिव है. नेक्स्ट केस अगेन, इसके तीन रीजंस बनते हैं. इसके जस्ट तीन रीजंस बनते हैं, ठीक है. आई एम गोइंग टू डिस्कस अबाउट इट. बट वन थिंग इज हियर, मेन इमेजेस आर मेनली, all the images are all the images are वर्चुअल. क्या होगा कि जितने सारे इमेजेस बनते हैं वो तुम्हारे मेनली वर्चुअल बनते हैं. तो इसका मतलब क्या होगा? वर्चुअल इमेज कहाँ परफॉर्म होगा? इंसिडेंट लाइट का जस्ट अपोजिट में, मतलब राइट साइड में बनेगा, है ना. सो इसका इसका मतलब क्या हुआ कि जो इमेज डिस्टेंसेस होते हैं 98% ऑफ केसेस में इसमें पॉजिटिव होते हैं. इमेज डिस्टेंस कैसे होते हैं गगन? ऑलवेज पॉजिटिव होते हैं, except one case. Okay, so that for that exception you'll have to wait till tomorrow morning 9:30 again, 9:30 a.m. I'm going to discuss about it, like how to take the image distance to be negative for convex mirror. Understood or not, Gagan? Are you able to get me or not? Any kind of doubt till now? No, no.
No, sir.
Okay, just stop.